Hi again. In this video, we're going to talk about center and spread. So we'll learn how to calculate measures of center and spread, and also which measures, because there's multiple options, which measures to use with each shape. Okay. So first of all, what are center and what is center and what is spread? We're always going to report these together, and they are statistics, so they will have units. We're always going to give the units. Center is think of the middle. It's the average or typical value. It's also called the position or location of the data. So think about where the data fall on the X or horizontal axis. That's like the position or location. So think of it as an average or typical value or location. And then the spread is how much variation there is in the data. So you can think of it as how wide or narrow the data are, how spread out they are. Okay, so I'll show you some examples of this, but center and spread go together. So there's two different sets that we're going to use. One set, which we'll do first, we'll learn how to calculate these, is the mean and the standard deviation. And the mean, when we're talking about a sample, the mean is represented by x bar and the standard deviation is the letter S. So we're going to use those for symmetric distribution. So that's really important. This is why we do shape first, so that we know which measures of center and spread to use. Then, if our shape is skewed, then instead we're going to use our median and our IQR, or that's short for interquartile range. Okay. Now the reason we're using different ones is the median with skewed, that means one tail's longer than the other, so there might be some outliers. So these measures are less sensitive to outliers. I'll show you that. So that's why we're using the median and the IQR for this. So you might have heard median household income. We use the median for that because if we took all those millionaires, billionaires, trillionaires, the 1%, they would, and we averaged all of our incomes together, that would bring the average way up. So that's why median is used, because that is the middle value, okay? Versus mean and standard deviation, these are a little more common. So if for symmetric, we use mean and standard deviation, because even though they are sensitive to outliers, we generally don't have outliers if it's a symmetric distribution. Now we could, but it's less common. Okay, so let's go ahead and do the first pair, mean and standard deviation. You might be familiar with the mean as the average, the regular average that you're used to. So the mean is the average of the data. We calculate this by adding up all the values and dividing by the number of values. And we have two different symbols for this, and we've seen this mu before. If we're talking about a population, then we use this Greek letter mu, which is spelled M-U, and it's pronounced mew like a cat, what a cat would say. And then the sample mean, if we have a sample and we calculate the mean, then it's labeled x bar. So that's x bar. Statisticians like to accessorize their variables. So a bar or a hat or some kind of accessory usually means it comes from data. Okay, so to calculate this, and we're most often going to have a sample, so I'm going to use x bar. So x bar, what we do is we sum up all the values and divide by the number of values we have. And this capital sigma means sum. So it looks a little daunting, but what it means is add up all the values. Sum or add. Okay, so let's do this and do a couple of examples and see what happens. Okay, let's say we've got data set A, and I'm going to say these are hours. I don't know the full context, but if I was going to do this, if I was going to write it out by hand, I would say x bar equals 3 plus 8 plus 12 plus 15 plus 18, all divided by 1, 2, 3, 4, 5. I've got 5 numbers. So I'm going to do that on my calculator. 3 plus 8 plus 12 plus 15 plus 18 is 56. Still divided by 5, so 56 over 5. Then I can divide by 5 on my calculator, and I get 11.2 hours. Okay. Probably familiar too, but if not, no worries. Okay, so let's do this again. And what I'm going to do is I'm going to add, for data set B, I'm going to add a value of 20 so you see what happens to the average. And then I'm going to add a value, instead of 20, 205 so you can see what happens. Okay, so let's do the next one, X bar. And remember, we'll be using technology mostly, but we're going to do one of each thing by hand so you get a sense of what the computer is doing. Okay, so same thing. I'm going to add these up. 3 plus 8 plus 12 plus 15 plus 18 plus 20. And now I should have 6 values. 1, 2, 3, 4, 5, 6. Okay. So I'm going to add, I could do a shortcut 56 plus 20, but I'm just going to do it. All 3 plus 8 plus 12 plus 15 plus 18 plus 20. Okay, 76, that makes sense. It should be just 20 more than we had last time. 76 over 6. Okay, how would you expect this to come out? So if we're talking about the middle and we added another number that's higher, our average should go up, right? We've got someone who's watched 20 hours of TV this week, so the average, that should pull the average up. Let's find out. 76 divided by 6 is 6, so it's 2/3. 12 point, I'm going to round that to 12.7. Okay, and I'm going to give you a rounding guideline for this as well, for means and standard deviations. So let's write that at the top. Rounding this is a guide because people see this differently. So statistics is less clear-cut than algebra or other fields of math. Not everyone agrees with each other, but the general rule that I've been told and I believe is that for a mean, we should go out one more decimal place than our actual data, because we want to be a little bit accurate. So think about if these were hours. My average 12.7 is in between 12 and 13, right? So that 0.7 gives me a little information of where that average falls. So for the mean, one more place than the data. Okay. And then I'm kind of running out of room here, but I'm going to give you a preview for the standard deviation. We're going to go one more than that. So we're going to go 2 more places than the data. Okay, in MyOpenMath, if it's a MyOpenMath question, just read the question very carefully. They'll tell you how many decimal places to put in. It may not match up with this. I'm going to try to make it match up with that, but just in case it doesn't, look for each individual question. Okay, so now we have data set C, and we have the same first 5 numbers, 3, 8, 12, 15, 18, but now we have a 205. So can you imagine what's going to happen to the average here? X bar is 3 plus 8 plus 12 plus 15 plus 18 plus 205. Someone watched 205 hours of TV in a week. I'm not sure if there's even that many hours in a week. I just made up that context since I didn't have it here. Okay, so let's see what we get. 3 plus 8 plus 12 plus 15 plus 18 plus 205. Okay, 261. Expected that to be large. And still out of 6. Okay, so this is kind of like what I was talking about with the income. This 205 is going to bring the average way up, right? Let's see what it is. 261 divided by 6, 43.5 hours. Okay, so if we were to use, this also demonstrates my point before, if we were to use 43.5 to describe this group of people and how many hours they spent watching TV, it's not very representative, right? Most people were 18 and below, but the average is 43.5 hours. So that's why we don't want to use the mean for skewed data. This would be skewed because we'd have this outlier way out to the right. So that's why we want to use, or we don't want to use, let me write that down. We don't use the mean for skewed data. Okay, because it's not representative of a typical value. Okay, so remember we talked about up above at the top of the note sheet, like the average or typical value or position or location. So it's not representative that one value is bringing it way up. Okay, I'm going to pause this video so that I can get the next notes page for standard deviation. Okay, I'm back and I've got the next notes page, which is on standard deviation. So standard deviation is a measure of spread. So the mean is the center, the standard deviation is the spread, used for symmetric data. So this one goes with the mean, and we'll actually use the mean in our calculation. So you'll see how that works. And the interpretation for the standard deviation is it's the average deviation from the mean. Okay, so it's kind of an average, but it's a little more complicated than that. So I'll show you how it works. I just want you to understand, I want to do it once by hand so you understand what it means, and then we're going to use technology to calculate it, okay? So I don't expect you to do really any of these. Unless you want to do a couple, that's fine, but I would rather you use the technology to do it. Okay, so first the symbols. Population standard deviation, we're using Greek letter, and this is a Greek letter sigma. Okay, some people say it's like an O, but it has a tail. So it's almost like drawing an O, but it's got a tail coming up the top. So I'm going to emphasize that tail a little bit because it's so small in this font. And then this, if it's coming from a sample, we use the letter S. Okay, I don't know why there's not an accessory on the S, but instead of sigma, we're using the letter S. Okay, now here's this formula for it. It looks a little daunting though. So I'm going to show you the process and show you how that correlates with the formula. Okay, so let's go to the formula, the example first, and I'll come back to the formula. You don't need to really use it or memorize it, but understanding what the standard deviation means is important. Okay, so here we have a sample, example 4, sample of 6 stat 243 students' students should be apostrophe at the end, heart rates measured in beats per minute. The mean of the set is 70. Calculate the deviation and squared deviation by hand, then calculate the variance and the standard deviation. Okay, so standard deviation is the average deviation from the mean. That's why we need the mean first. So I'm just going to double check that the mean is 70 before I get started. 52 plus 68 plus 70 plus 72 plus 73 plus 85. I've got 1, 2, 3, 4, 5, 6 numbers. So they add up to 420. If I divide by 6, I do get 70. Okay, great. So 70 beats per minute. Didn't put my units there. Okay, so the first thing we're going to do is subtract 70 from each number. We want to know how far is each person from the mean. So I'm going to subtract 70, and that's what deviation means. Deviation or distance. You could think of it as distance. And I'm going to use my calculator for this. So 52 minus 70. Notice it's going to be negative because I'm subtracting more than I have, and that's fine. Some will be smaller than the mean and they'll be negative. So that's negative 18. 68 minus 70, that's 2 away, so that's negative 2. 70 minus 70, as you can guess, that's 0. So that person was right on the mean. They happen to have the average heart rate or pulse rate. 72 minus 70, I'm sure you can do some of these in your head as well. That's fine. 2. 73 minus 70 should be 3. And 85 minus 70 is quite a bit larger. That's 15 away. So this person was quite a ways above the average. Okay, let me fix my paper here. Okay, so we've got our deviations. Now, we don't want to just add these together because, like, we're taking an average, right? So you think add them up and divide by the total. We don't want to just add these as is because some are positive and some are negative and they'll cancel out. Okay, so what we do is we square them. So we square each deviation, and I will go ahead and write that in this table as well. So I'm going to put negative 18 squared, and I'm going to put it in parentheses because if you type it in a calculator without the parentheses, it'll stay negative. If we want to square the negative with the number, the whole number, including the sign, we need to put parentheses around it. So I'm going to put parentheses negative 2 squared. Or you could also just know that a negative squared is a negative times a negative, and so it's positive. 0 squared, 2 squared, 3 squared, going down the table, and 15 squared. Okay, so those will be my numbers. So let me calculate those. Parenthesis negative 18 parenthesis squared. So you're going to find, depending on what calculator you have, let me show you how I did that. Parenthesis, I've got a negative symbol at the bottom here. Negative 18, close parenthesis, and then I have an x squared button here, but you might, if you just have a caret button, caret 2 works as well, but there's often a shortcut for square because it's so common. Okay, that's 18 times 18 is 324. Big number, right? Okay, let's do negative 2 squared. So parenthesis negative 2 parenthesis squared. Should be 4, right? 2 times 2 is 4. 0 times 0 is 0. 2 times 2, 2 times itself is 4. 3 times itself is 9. And I think I know 15 squared, but I'm not going to chance it. I think it's 225. Let's see. 15 squared. Bingo, 225. Okay, so we've got all these squares. So in our deviations, these are still beats per minute, right? And in our pink ones and our heart rates, these are beats per minute. But now that we've squared the numbers, these are no longer beats per minute. So this is really like beats per minute squared. So we kind of lost the meaning with that. I don't know what that means. It doesn't mean anything. So we've kind of lost the meaning. But notice how now all of our deviations are positive, or squared deviations are positive. So we can add that up and get a total. The other thing squaring does is it emphasizes the points that are further away. So notice right on the mean doesn't contribute anything. If you're 2 away, 4, 3 away is 9. 15 away is 225, 18 away is 324. So squaring also emphasizes the numbers or the values further away, further from the mean. It's another thing it does. It also makes them positive. Let's say that's 2 squaring. Let's say gives us positive values. Okay, great. So now in our table, the next cell down, the bottom row says sum of the squared deviations. So sum means add, so we're going to add up this column. Okay, let's get my calculator in frame. So 324 plus 4 plus 0 plus 4 plus 9 plus 225 gives us a total of 566. Okay, I'm going to keep going and do the variance, and I'll show you how this is the formula that you see at the top of the page. The variance is called S squared, is our symbol for that. It's the sum of the squared deviations divided by n minus 1. Okay, so usually in an average we divide by n, the number of numbers we have. But there's a thing called degrees of freedom, which we did mention before in the Kiki Booba video. There's 2 questions, but in the case of that, it was really only choosing one. There's one choice to make, and then the other one was fixed. So the idea is if you've decided all the values, the last one is fixed. So that's degrees of freedom is n minus 1. It's a difficult thing to explain. You won't have to explain it. You'll just have to use it. So it's this sum of the square deviations divided by n minus 1. So it's 566, the number we got from our table. And then how many values did we have? We had 1, 2, 3, 4, 5, 6. So we're going to divide by 6 minus 1. Okay? Or in other words, 5. So I'm going to rewrite it as 566 divided by 5. Let's see what that is. Divided by 5, 113.2 beats per minute. Oh, sorry. I'm in the variance, so I'm not beats per minute yet. We won't deal a lot with the variance, but it's just good to know the name. The variance is before you take the square root. So essentially, we want to get back to beats per minute. So we're going to take the square root to get the standard deviation. So the variance is the square of the standard deviation. That's why it's S and S squared. So let's do the square root of 566 over 6 minus 1. You could go right to that step and just skip the variance if you want. So if I do that, if I do it that way, I would put it in my calculator like this. And you can also use desmos.com for a calculator if you prefer that. So I do have a square root button right here. So I do second square root, 566 divided by 5. And that is 10 point. Now remember I said 2 decimal places beyond the data. So I'm going to go 2 places, 10.64 beats per minute. Okay, now that seems reasonable. 113.2 is really big. So if you get a really big number, think, oh, maybe I forgot to take the square root. Okay, and we'll check that on Staplet.com in just a minute. I just want to go back up here to the formula and show you the symbols and how that all works. But again, you don't have to, don't worry about the symbols because you don't have to use them. Okay, so xi is our individual x value, so 52, 68, 70. We have the summation of a difference here, xi minus x bar. So that's the first thing we did, was we took each value and we subtracted the mean, right? So that's our difference, and then parentheses squared. So then we're going to take each difference or each deviation and square it. So that's the next thing we did. And then we summed those all up. So that's what that capital sigma summation is. That means add. We added all those up. Then we divided by n minus 1. And if we stopped there, we'd have the variance. But we want the standard deviation. So we go ahead and take the square root of that. That gets us back to our original units. And that is our standard deviation. Okay, and I'm just going to remind you here that we're going to round to 2 more decimal places. Than the data. So if our data had decimals and had 1-digit decimals, then we would go to 3. So we just want to be a little bit more accurate or a little bit more precise than our actual data, because it's usually in between our data values. Okay, so for Staplet, I believe I still have what we did earlier over here. So let me pull this over here and let's check. Oh, it's a different data set. Never mind. Okay, well, that's okay. Let me show you what we would do. Let me go back up here. What you do is reset everything. So let's say you've done this, but now you're doing a new question. So I'm going to hit reset everything. And then our variable name is pulse rates beats per minute. And I'm just going to go ahead and type this one since there's not that many. 52, 68, space 70, space 72, space 73, space 85. Okay, so let's say you were doing this for your homework. Begin analysis. Now we're not as concerned about our graph, right? Here we're mostly trying to get our summary statistics. So we can see our n, that's the number of data values we have. So we can double check that. We had 6 values. Our mean was 70 beats per minute. We found that. Our standard deviation, they're saying 10.6395. They're generally going to give more decimal places, like up to 4. They're not using the same rule that I am, but we can just do that ourselves. So 10.64, that's exactly what we got. And then we'll talk about the rest of these later on, okay? So what you can do if it asks you for a standard deviation is you're going to put it into Staplet, okay? But now I think you have a sense, let me move this out of the way. I think you have a sense now of how it's the average deviation from the mean. So on average, the people's pulse rates was 10.64 away from the mean. And so it kind of is an average. Like we had some 0 away, 2 away on each side, 3 away, and then the 15 and 18. So those really brought that average up, right? That's the average from the mean. Okay, so we did check our standard deviation using Staplett.com. So I'm going to put check right there. Okay, now let's say we were going to write a paragraph, and this is part of it, center and spread. So let's write what we would put for that. So if we had a symmetric, and this is fairly symmetric, if we had a symmetric data set, then we could write something like the mean of the heart rates is, we had 70 beats per minute, which varies on average from the mean by 10.64 beats per minute. This is why I think communication really helps people, because putting the units on something helps people understand what we're doing. And the standard deviation has the same units as the mean and the same units as the data. Okay? Okay, so I know that was a long one. I hope that helps with the mean and standard deviation. And I will see you in the next video where we'll talk about, I believe we're talking about median and interquartile range. Okay, see you there.